So one of the main uses for differentiation is to find what's called the equation of the tangent and the normal. And this is what a tangent looks like. The tangent is the line which, very, very close to the point, looks the same as the curve. So if we zoom in on the point 1, 2 here, then the curve and the line are practically identical. The more you zoom in, the more identical they are. But obviously the more you zoom out, the more different they are. So what we're actually saying is, what is the equation of this line? And what do we write down when it's a question about an equation of a line?
The form that you like.
Yes? There's a thing. Any question, any question about any sort of equation of a line, we write this down, don't we? M, x minus a is 1 minus b. Okay? So, because we're looking for the equation of the tangent, a tangent is a line, so we write m, x minus a is 1 minus b. And then we think about, do we know a point on the line? Yes, we do. 1, 2.
Yeah.
Do we know the gradient? Oh, okay. We're told that the graph is y equals 3x minus x squared. We want to know the gradient, so we differentiate. Then we say we want to know the gradient when x is 1, because this is the gradient at any point.
Yeah.
When x is 1, what's the gradient? The gradient is 3 minus 2 lots of 1. The gradient is 1. Hooray! Now I know the gradient, now I know the equation of the line. So it's nothing new. We've already done all of it. A tangent is a type of line. We know how to find the equation of a line. The only bit we're missing is the gradient. We know how to find the gradient. Nothing new. A normal is the line which is perpendicular to the tangent.
Yeah.
So it goes through the same point, but it's perpendicular. It's still a line, so we still start by writing m, x minus a is 1 minus b. It's still going through the point 1, 2.
Yep.
The gradient we still find by finding the gradient function, but when we find the gradient at x is 1, what we found there is the gradient of the tangent, and what we want here is the gradient of the normal, which is perpendicular, so we need the negative reciprocal. So it'll be minus 1 over 1, which is minus 1, and then that's the gradient of the line. That's the equation of the line. So several skills that you've learnt already, all brought into one question. Have a go. See how you get on.
This old chestnut again. Same equation. So what is the equation of the tangent? We don't want the normal, look at the tangent.
Yep.
At x equals minus 1.
Yep. So you're going to write down m x minus a is y minus b. Yeah, good. And the reason you're writing that down is because you know that you're trying to find the equation of a line, and this is the equation of a line.
Yeah.
Yeah? And a tangent is a type of line, and we know that to find the equation of any line, we write mx minus a is 1 minus b, and then we think, do we know a point on the line? Do we know the gradient?
Okay, so to find that point on the line, we know we've got an x value of x equals minus 1.
Yeah. So
So
that goes there.
Yeah. I'm going to do that over here. Plus 1.
Yeah. So 2 bits missing.
Yeah, so then we can work out what the y coordinate of b value is.
Yeah, because the b is the y coordinate corresponding to the x coordinate minus 1. So we need that function here, and it's going to tell us what the y coordinate is. Yep.
It's minus 2, minus 1, minus 2, minus 1.
Yeah. Minus 6.
Minus 6. So
Yeah.
this step now, x plus 1, we had that before.
Yeah.
Y plus 6.
Exactly. So we haven't even needed to do any differentiation yet. It was just, we know the x coordinate, what's the y coordinate? Now we need the gradient.
Yeah. So we need to do dy by dx, which is 6x squared. I think I could do this one in my sleep now. Or the other video. It's 2.
Yep.
And we want it where we want the gradient at x is minus 1.
Yeah, so this we don't know, but we do know that x is minus 1. In the same way that we didn't know y,
Yeah.
But we did know that x was minus 1.
Yeah, so we don't know what that is, but we do know that 6 minus 1 squared minus 2 minus 1 plus 2,
Yep.
which is 6 plus 2 plus 2, which is 10.
Yep.
So
that's
dy by dx, which is the gradient, is
Yeah.
10,
Yeah.
and then that goes in there,
Yeah.
and we get 10 x plus 1, y plus 6.
Yeah, and then if you want it in a particular form, then fine, rearrange it. If not, that's fine. Great, try this one.
What is the equation of the normal at x minus 2? Okay, so we are doing the equation of the line x minus a, y minus b. We know that x is minus 2, so y is that.
Yep, good start.
B.
Right,
we
B
need to
next.
find b, exactly,
Okay.
yeah. So y is the bit we're trying to find, so
Yeah.
our coordinate, we're going to do 2 minus 2 cubed minus 2 squared plus 2 minus 2 minus 1, there's a lot of minus 2's in that. 16, no, minus 16.
Minus 16.
Minus 4,
Yep.
minus 4, minus 1,
Yep.
minus 25.
Mm-hmm.
So we can now fill in that bit, and it's 2, or that already, it's y plus 25.
Great.
Now we need the gradient,
Yes.
which we're going to need to do by differentiating, which is 6x squared minus 2x plus 2 at the point x equals minus 2. So we don't know what the actual gradient is, that's what
No.
we're going to find, but we know this point. So
Yep, x is minus 2, so we can sub in x is minus 2.
4, 6, 4 is 24.
Mm-hmm.
Plus 4 plus 2, which is 30.
Yep.
So that's dy by dx.
Yep, so that's the gradient of the tangent.
That's the tangent. So to do the gradient of the normal, we need the negative reciprocal.
Yep.
So for normal, we need minus negative reciprocal.
Yep,
Like
exactly.
30. Right, so then that goes into there.
Mm-hmm.
Minus 30 minus x plus 2 y plus 25. Again, we rearrange if we need to.
Yeah, equals. Yeah, exactly. Done. Right, there's a couple here for you to try yourself. So have a go, just try it yourself. Pause the video, try it yourself quickly, and then unpause the video and see how you got on. So, tangent, type of line, m, x minus a is y minus b. We know that x is 2, so x minus 2 goes here. Y minus, we need to find the y coordinate. So we find the y coordinate by subbing 2 into the original equation. And that gives us 12 minus 4 and 5, which is 13.
Yep.
So that's 13 there. And we need m, so we need dy by dx. That's the gradient function. That's 6x minus 2. Then we put in our value of x, which is 2. So at x is 2, dy by dx is equal to 6 x of 2 minus 2, which is 10.
Yep.
So the gradient of the tangent is 10, and that goes there, and then we're done. Unless we have to write it in another form. Okay, next one, gradient, the equation of the normal. Normal is a type of line, so we write m, x minus a is y minus b. We know that x is minus 2, so we get x plus 2 there. We will find out what y is when x is minus 2 by subbing the minus 2 into the original equation. 2 lots of minus 2 add 5, which is 12 add 4 add 5, which is 21. So that's y minus 21. Then we need the gradient, so we need dy by dx. dy by dx is 6x minus 2, and at the point x is minus 2, dy by dx would equal 6 lots of minus 2 minus 2, which is minus 14. But we want the normal, in this case, not the gradient of the tangent. The gradient of the normal will be the negative reciprocal of that gradient, which is 1 over 14, and then we're done unless we need it in a particular form.